Let's take a look at another application problem. So we want to find all points on the line y equal x plus 1 that are 4 units away from the point 1, 0. So let's draw a picture of what we want. So we know what the line y equal x plus 1 looks like. It's got y-intercept 1, and it's got slope 1, so we can find a couple other points on there, right, those two, and we can draw the picture of our line. All right, so here it is. Maybe draw a little better line there that actually does go through those points. Okay, great. So there's the line y equals x plus 1. So we want every point on that line that is 4 units away from the point 1, 0. So the point 1, 0 is right there. Okay, so if we want to be 4 units away from that, we can kind of see in our head, right, 4 units. I want to put a line segment of length 4 that connects that line to the point. And it doesn't exactly matter how we draw our picture because we're not going to get the information from our picture. We're just going to kind of get an idea of what it is that we want to do from our picture, right? So I've got my point 1, 0, and then we've got 2 guys up here, and now we have to find these things. So we're going to use something that we did in section 1.1, the distance formula, right? So if I want the distance between 2 points, any 2 points here to be 4, I know that those 2 points are going to have to satisfy that distance formula. So well, let's just write what we want. We want all points so that the point is on the line. And the distance from 1, 0 is 4. Okay, so remember this nice distance formula that we had, right? We had the difference in the x coordinates, the difference in the y coordinates, and we squared them, right? This came from the Pythagorean theorem. We'll remember the nice distance formula. We can, reference the textbook if we'd like to see where it comes from. But anyway, to use this thing, we're going to need 2 points, aren't we? And it looks like we've only got 1. Right, so we can use this for x sub 0, y sub 0, so that's fine. And this is going to be our distance, but we don't exactly know what x sub 1, y sub 1 are. But we do know that this must be on the line. And we can say what the coordinates for that will have to be, well, using the equation for the line. So something that we can maybe think about is how we drew these before we knew that this was a line, before we knew that it had slope 1, y-intercept 1. We just plotted points, right? So we put, put your buddies in there. And to find any y values, we're always just going to put whatever we put in there, we're going to put it right there for x. So I'd have -1 plus 1, well, that's 0. I'd have 0 plus 1, that's 1. I'd have 1 plus 1, that's 1. 1, it's 2, right? 1 plus 1 is 2. Okay, well, that gave us ordered pairs. And we can list them, right? -1, 0, 0, 1, 1, 2. Those are all ordered pairs on there. Well, see the pattern, right? Every time I put a number in here, all we're going to do is just add 1 to it. So anytime I put anything in there, I'm always just going to have x plus 1, aren't we? And this is going to give us our ordered pair, right? We got our x, and now whatever x is, I'm just going to add 1 to it to get my y value, right? So if this point is on the line, then we're going to use the point that has to be there, right? X comma x plus 1. Okay, good. So now we have an ordered pair that we can use in our beautiful little formula. We're just going to call these coordinates here x sub 1, y sub 1 in the little formula. I guess I had that written there anyway. Okay, so let's put all this stuff in there. We got 4 has to be our distance, so there's 4. And then we're going to put in x sub 1 here. X sub 1 is just x. And then minus x sub 0, we're using 0 for that. And then we've got y sub 1. That's y sub 1 is right there. And then y sub 0, that's this guy. Wait, I put that in the wrong order. Excuse me. This one's a 1. Sorry about that. And then this one's going to be that 0. Okay, good. Now we're back on the right track. So now this must be true. So if the point x comma x plus 1 is 4 units away from the point 1 comma 0, then this must be true. And we can just solve for x and find the value that makes it true. So let's go ahead and do that. We can we have general strategies for how to solve equations here. We've got the stuff we want is under the radical. So what we're going to do is square both sides, and it's going to get rid of that radical. So we got 16 on the left, and then square a square root, it just goes away. And then this guy we can simplify, x plus 1 quantity squared. So now 16 has to be this, and we're kind of just going through the motions here solving a quadratic equation. We've done this a bunch of times, and we have wonderful methods that we do, or that we can use. Hopefully when we get this all multiplied out and everything on one side, we can factor. But if we can't, we also have the nice quadratic formula that we can fall back on, right? So this guy, we got x squared plus 2x plus 1. We're just squaring the binomials there. And now we collect all of our like terms. We know that we're going to want 0 on one side, so let's go ahead and put that there first and start collecting like terms. So we got x squared plus x squared, negative 2x plus 2x. So those terms cancel out. That's good. We got 1 plus 1, so we have plus 2, and then minus 16. Can't forget about that. Okay, so now we have 0 equals 2x squared minus 14. And good. So at this point, we can almost thank our lucky stars here that we don't have to do the little quadratic formula, because this one has a pretty simple form here, right? If we can isolate that x squared stuff, we're home free. So we can put this 14 back on the other side, and then divide by 2, and do our square root bit. Okay, so bringing this back to what we were doing, we've just found the x coordinates of the points that we want. So we need the y coordinate now. So real quick, remembering what it was that we were doing, we had a line, right? There it was, and we had a point, and we wanted to find the points that were 4 units away, so they were like there and there. Well, this is what we found. We found the x value here of these ordered pairs, right? So happy days, right? So now we just need the y values, and we can find the y values just like we had up above. We were taking our x and then our y. We just put square root of 7 in there. So we got square root of 7 plus 1. And we would have negative square root of 7 in there. Well, negative square root of 7 plus 1, right? We just put whatever x value is here. We plop it in there for y. And there we go. We've got our ordered pairs. We've got square root of 7 goes with 7 plus 1, square root of 7. And we've also got negative square root of 7, comma, negative square root of 7 plus 1. And we have our ordered pairs. And we can go on our happy way. So really, though, I think that the difficulty with this problem hopefully wasn't in solving the quadratic equation. We've been doing that for quite a while. Really, I think the difficulty for most students is right here, where we have to say, I'm on the line, give me an ordered pair that's on that line. We could see this with parabolas sometimes as well, right? Maybe if just a real quick another example of this, if I have a parabola y equal, I don't know, x minus 5 squared plus 2, and if I wanted an ordered pair on this parabola, it must look like x comma, and then whatever you put in there. So we would have x minus 5 squared plus 2, right? Because that's the y value. Okay, so we can, we'll see this again in the future, maybe with just like a polynomial in general. So yeah, we can do it, right? Any ordered pair that's on a graph is going to have to look like X comma and then whatever the Y value is when you put that X in there. Okay, great. So if you've got questions about this or anything else, please let me know, and we can have a chat. So have a great rest of your day.